On today's episode, I'm going to go through all the steps necessary to configure your BL Touch to use with Klipper firmware. We make some additions to our printer.cfg for initialization. We're going to go through some sanity checks. I'm going to go through the X and Y offset for your given shroud. We're going to adjust our Z offset, which of course is great for that first layer adhesion. And then finally, I go over how to create the correct probing bed mesh, which I think gives people the most headaches. You often get a movement out of range issue. I'm going to show you all the adjustments necessary to make sure that goes away. And here we go. Folks, welcome to the channel. I am Leo of Prince Leo 3T. Thank you for joining me today in our ongoing series of getting your 3D printer ready for Klipper firmware. In today's video, we're going to go over the BL Touch. Now, no matter what printer you have, however, this information should all apply to you. This is meant to be universal, so you should be able to take these concepts and use them on your current printer. Now, in this video, I'm going to say the word BL Touch a lot. I don't necessarily only mean the BL Touch. This is going to be any auto bed leveler similar to it. So a CR Touch, of course a BL Touch, any of the various clones, a 3D Man, a 3D Touch. Whenever I say BL Touch today, I'm talking about all of those, just using BL Touch as shorthand as it was the original bed probing device. Now, there are several steps in our process to make sure the BL Touch is up and running, and I recommend you go from the bottom all the way to the top and don't miss any in between. Even the beginning sanity checks are necessary just to make sure everything's working like it should. And then all the offsets we use, our X, Y, and our Z offset, all get applied further in the video using different things. So you want to make sure you have those as accurate as possible. And in this video, we go over that. Now, to start, we're going to begin in our printer.cfg because we need to add a few sections to initialize our BL Touch so Klipper knows that we have one and how to work with it. And of course, that starts on your front end. And for me, I'm using Fluid. Our BL Touch setup starts in our front end, and we're looking to make some edits to our printer.cfg. Open your printer.cfg, and you're going to paste in the following three sections, and I'm going to go through them one by one. The first section is BL Touch. The top two areas here are the pins that are dedicated to your specific board, so these will be different for every main board. Below the pins are the X and Y offsets for our BL Touch. These are extremely important, and we're going to calibrate them today. But for now, we need to have some values in there, so you can stick with whatever you've pasted in. Below that is samples, and that's the number of probes our BL Touch will take at each probing point. Speed is the speed at which our BL Touch is going to move in position when we do the Z offset calibrate, both in the Z and the X and Y directions. And then Z offset, this is something we're going to calibrate also later in the video. It needs to be uncommented and have some value. Normally it would just be 0.0, which is perfectly fine. The next section we're going to paste in here is called Safe Z Home, and this is the location of where the BL Touch is going to home after the X and Y end stops are triggered. In general, it should be somewhere around the middle of your build plate. Speed is the speed at which the movement will take place. 50 is perfectly normal. Z Hop is how far the X axis is going to raise off the bed after you are finished homing. I like to keep it at 10, and the Z Hop speed is the speed at which it will do that. Now, to get our BL Touch configured, these are the only two sections we currently need. We are going to add a bed mesh section, and that will determine the exact probing grid of our BL Touch. But for now, we only need these two sections. And we also need to amend another section, and that is under stepper Z. Under stepper Z, we have an end stop pin, and this needs to be changed. You can erase everything that's after it, and you can paste in this new line, probe, Z, virtual end stop. And then we're going to comment out the position end stop. This is all being handled within the BL Touch section already. I'm going to save, then I'm going to restart my firmware so everything takes effect. I've restarted the firmware, everything is working, so now it is time for everyone's favorite sanity checks. We love these. Everything is going to be done now through the console of the printer's front end. So we start here. And this is the first line we're going to send. This should force the pin on the BL Touch to extend and for the light in the housing to turn off. After that command, we're going to ask it to retract using this command. Now the pin should retract and the light should illuminate again. If all those are working fine, we can move forward. We're going to ask the pin to move down again. And this time we're going to put it in touch mode, which means it's going to respond to us with its current state, whether it's open, meaning it wants to probe a point, or triggered, meaning it has already probed a point and it's retracted back into its housing. I use this line and it returns its current state, open. That's exactly what it should return. If that pin is extended, the return result should be open. Now very gently with my finger, I push the pin back into the housing, it retracts, and the light turns back on. I send the same command I just did, and the return should be triggered, which is exactly what it is. That means my BL Touch is working as it is intended. If you ran into any issues here, if it wasn't deploying, if it was deploying but giving you the wrong state, open when it was triggered, triggered when it was open, you can go to my website. I discuss exactly what each one of those errors means and what some possible fixes are. My BL Touch is working fine though. So what I'm going to do is turn my motors off. Then I'm going to manually raise my X-axis pretty high because I want to auto home this, but I want to stop it with my hand just to make sure it's not going to careen into my bed. And now I can auto home. And during the descent, the home of the Z-axis, I'm going to very gently push up that pin of the BL Touch, making sure it does in fact stop my nozzle from moving down. It should stop. And if it does, you now know you can safely auto home your machine because your BL Touch is definitely working as it is intended to. Now we start with the different offset adjustments. And the first one we're going to begin with is the X and Y offset. We're going to use a post-it note and then something to write on that post-it note. We're going to fix it under our probe tip. And then we're going to go to our front end and we're going to move our nozzle over this and we're going to find out just how far our probe tip is from our nozzle. To do this calibration, we're not going to need a ruler or a caliper, anything like that. All we need is a post-it note and we need to make a mark on that post-it note. So you're going to need a marker. Then we home our machine and our goal is to put the post-it note on the bed with the dot directly below the probe tip on our BL Touch. If you want, like I do, you can use the command line and tell the BL Touch to extend its probe pin. This just helps if the probe tip is far enough away where you can't quite see if it's lined up. Of course, if you do that, make sure you do retract the probe tip with the correct command. Once you have your post-it lined up, go back to the home screen of Fluid and take a note of the current coordinates. Write them down somewhere because we're going to use them in a formula at the end of this. Now using the controls of the printer's front end, I want to move the nozzle tip directly over the mark that the probe tip was at. Now it doesn't matter if you overshoot it or undershoot it so long as you get that nozzle directly over the mark. And it may help to lower the Z-axis so the nozzle closer to the bed and you can see a lot better if the nozzle is in fact lined up. Once the nozzle is over the mark, we take the current coordinates. My ending coordinates were 82.5 in the X and the Y was 119. And now it's a simple math equation. I take my ending coordinates and from it I subtract my starting coordinates. And yes, it is possible you might end up with a negative number. So for me, I'll start with my X coordinates, 82.5, and from it I subtract 125, and I end up with negative 42.5. That is my offset in the X direction. Write that down somewhere. And now to compute the Y offset, I take 119, I subtract 125, and I get negative 6. So now I can go back into my printer.cfg and then make the necessary changes. I go into the BL Touch section and I add in my X offset, which was negative 42.5. Then underneath that, I add in my Y offset, which was negative 6. I can save my firmware, but I make sure to restart so it takes effect. Now don't throw that post-it away. We're going to use it for this next step, and that's for the adjustment of our Z offset. And Z offset is similar to the X and Y offset. It's the distance the probe tip is from the nozzle in the Z axis, or the height that it is different. Now Klipper has onboard commands to run this calibration for us, so we jump back on our front end and we do everything from there. Before we start our Z offset calibration, I want you to jump back into printer.cfg, which you're going to be sick of me saying this, but we make all our changes here. We're going to now go down to stepper Z, and you need to add a section if it's not here called position min. And you're going to want to make position min negative 6 because we're going to be taking up the gap between our probe tip and our nozzle. We're going to be moving the nozzle closer to the bed. We need to have a negative minimum distance so that the nozzle can correctly travel as close to the bed as possible. Negative 6 should be perfectly fine. If during the Z offset calibration you run into a movement error, you may need to come back in here and decrease that position minimum. After doing this, save, restart your firmware. Our Z offset calibration will also take place at the command line. And before we do, we need to auto home our machine. And then we can run the line probe_calibrate. Probe calibrate rehomes the Z axis and then moves the printhead into a position based on the X and Y offsets of our BL Touch that we already input. Then a new screen comes up, and this allows us to adjust the height of the nozzle. Now, the Z offset adjustment is just that, a height adjustment. Looking at the menu right here, you'll see that there are measurements right in the center, and those are in millimeters. The subtraction sign lowers the nozzle closer to the bed, and the plus sign moves the nozzle further away from the bed. Because my nozzle is so far away from the bed at start, I'm going to move in the largest number available, which is 1 millimeter. So I start making those negative millimeter adjustments. As I get closer to the bed, I am constantly looking. And when I get close enough where I think 1 millimeter movement is too much, I start making smaller adjustments. At some point, I go too far down and I increase the distance in small increments until I can get my post-it note back under there and I feel the adequate drag. Once I feel comfortable there is good tension on my post-it note, but I can still move it, I accept that position by clicking the accept button. It doesn't save into our printer.cfg just yet. We need to save it ourselves. You can click on the save_config command, which populates it in your command line, and you can send it through there. Or what I like to do is the disk at top. If you click that, a new menu opens up and it shows you all the settings that will be saved. And right here, it shows us our BL Touch Z offset setting is going to be saved. And when I'm all finished, I can enter my printer.cfg. I look at the BL Touch section and now the Z offset has been commented out. And if we go to the bottom of this file, and my BL Touch Z offset is saved right down here. To begin calibrating our bed mesh, we need to first make some additions to our printer.cfg just like we did earlier. We're going to add the section bed mesh, and you can copy and paste this starting from the top. Speed is the speed at which we will move between probing points. Below that, horizontal move Z. This is how far the probe or the nozzle is going to rise after it probes. Mesh min and mesh max. These are the two most important parts to this section, and together they provide two coordinates that will create a boundary box that our probe will stay within while it performs the probing routine. This is what we will calculate today. These need to have values, though. For now, you can keep something just like I have in here. Probe count. This is how many probe points you're going to get along the X and the Y axes. Right now I have it as 5, a total of 25 probing points. Mesh PPS. This is the amount of points that Klipper will calculate between physical probing points. So while we're only getting 25 probed points, Klipper is going to compute a whole lot more to get an accurate picture of our bed. Fade start and fade end. At some point, we want to stop using our mesh to adjust towards the contour of our bed. That is what these fade parameters determine. Fade start is the value in millimeters at which we will begin to decrease the effect of the probed mesh. Fade end is the height in millimeters that it will terminate completely. Between those 2 points, it will gradually lessen effect. That is the only section we need to include for bed mesh, but the important parts are right here, the mesh min and mesh max, and we're going to get into how to find those right now. But not before saving and restarting your firmware. Now, when finding the coordinates for our mesh min and our mesh max, there is a simple way and there is a thorough way, and I will show you both. The simple way is actually a great way to understand the concept of what we're doing, and then that thorough way just gives you an extra few percentage points when finding the maximum bounds of your probing grid. Now, we're going to start with the simple method, and like I said, this helps to understand the core concept of what we're doing. Right here, I have a top-down view of my build plate, and I have a diagram on the center that represents the nozzle as a white circle. The yellow square is our shroud, and the gray circle is the probe. These items are together meant to represent the printhead. And the first thing we're going to do in the simple method is home our machine, and your printhead should end up in a similar location to where you see it now. After homing, you're going to enter the coordinates x0, y0, and that will bring your printhead to the origin point. It's from this point we will determine our minimum mesh value. Now you'll see at the origin, my probe is off the bed, and this would be a horrible value. If I tried to use this, my probe would never contact anything, and my nozzle would crash into the bed. It's at this point we're going to use the movement commands and move our probe over to a location that we want to start probing at. In general, I prefer it to be 10 millimeters off the bed in each direction, but it's completely up to you. Once you get the probe in a location you think is a great starting point for your probing mesh, you're going to find out what the probe's location is. How do we do that? Well, we need to use the nozzle's location. In this scenario, my nozzle is located at 5316. We get this information from the coordinate system of our front end. Using the nozzle's location, we then add to it our X and Y offsets on our BL Touch. In this scenario, the nozzle was 5316, and my offsets were -42.5, which I rounded to -43, and the Y was -6. We add those two numbers together, and that will give the coordinates of our probe, which is X equals 10, Y equals 10. That number now becomes our mesh minimum value. And that coordinate will create two barriers where the probe will have to stay in while it's creating the mesh. And now we're going to find the mesh maximum coordinate. To do that, we need to find what the maximum bounds are for our X and Y directions. In printer.cfg, you can look under stepper X, and position max will tell you the maximum position it can be in. And for me, it was 225. Now, under the stepper Y section, look for the same heading, position max, and again, for me, it was 225. That means my maximum position in the X and Y axes is 225, 225. Back on the front end of our printer, we add that into our coordinate system, and the printhead snaps to that location. Because this is the maximum bounds of my printhead, I can go no further to the right or further up. My probe is at its maximum point. Now, unless I wanted to start decreasing my probing grid, this is the location I need to use. And to use this location, we need to know the probe's coordinate. To get that, we use the same formula we did for the minimum values. We take the current position of our nozzle, which is 225X, 225Y, and then to it, we add our X and Y BL Touch offsets. I added -43 as an X and -6 as a Y. That gives me the probe's position of 182 in the X and 219 in the Y. That coordinate now becomes the mesh max value. And together, those two coordinates that we've calculated create a box that your probing points will all stay within while the BL Touch is creating your bed mesh. And now it's on to the more thorough method. And to perform this, you need to have watched the simple version because the core concept of what we did there is going to apply here. The only difference for this version is we are going to personally find out what the movable bounds of our printer are. With the simple version, we relied upon whatever printer.cfg you copied, pasted, or downloaded. And oftentimes those movable bounds are kept conservative so your printhead doesn't cause any damage. But now we're going to increase our maximum bounds, and we're going to personally find out how far our printhead can move, which should give us a few extra millimeters in the X and Y direction, which translates to additional probing range. We start in printer.cfg, and I'm looking for the stepper X section. Under the heading position max, we're going to add 100 to whatever the current value is. For me, it's 225, so I'm going to make the value 325. And then under that, we're going to add a new section, position min, and we're going to make it -10. Then find the value for position end stop and make it 0 if it isn't already. After this, we're going to do the same exact thing to stepper Y. Change the position max to 100 over the value it is now. Then you're going to add a position minimum section if there's not one there already. Make it -10, and then find position end stop and set it to 0. You can now save and restart your firmware and auto home your machine. From this position, we're going to go to the origin point, which is 0, 0. So I input that into the coordinate system, and the printhead moves to it. Now at the origin, the nozzle should be over the front left corner of the bed for this Ender 3. You can tell though it is not. I am a little bit off in the X and the Y direction. Using the movement controls, I'm going to attempt to move the nozzle to the front left corner. All of these movements are going to be in 1 millimeter increments, and I start on the X axis. I move it 1 millimeter and it goes without hitting a stop. However, when I try to move it over another millimeter, the printhead slams into the end stop. That means the position prior to that, -1, is the farthest point we can go. So we write that down. And now I start on the Y axis. I start moving the bed up in a positive number until my nozzle is over the bed. I'm doing this in 1 millimeter increments. And by the 6th millimeter, I'm at a location where I think is appropriate. So now you can take note of that number. And we can head back in to printer.cfg. Under stepper X, we're going to find position end stop. We're going to make this number the inverse of the value we just got. For my testing, I got -1. So the position end stop becomes the inverse, +1. Because my position end stop is in the positive, I can now get rid of my position minimum. I don't need it anymore. Then we move to stepper Y. Position end stop becomes the inverse of the value I recorded. For me, that value was 6. So position end stop becomes the inverse, -6. Because our end stop is in the negative. I now need to match position minimum to this number. So I make position minimum -6. Now I can save and I can restart my firmware. And now we will find out the maximum values of the X and the Y axes. In the previous step, when we adjusted our minimum values, we moved the origin point back to being on the bed, which means we will now get a more accurate area based on our minimum and our maximum coordinates for our BL Touch to probe. After auto homing, I start along the X axis. My printer.cfg had 225 as the previous position max, so that's what I input to my X coordinate, and I let my printhead travel there. Now, in 1 millimeter increments, I begin to increase the value along my X axis. We're doing this to find our maximum position. And that maximum position will be defined in one of two ways. Either you will hit the side of the printer, you can go no further, or your print head will begin to rise up because the wheels or part of the gantry is rubbing onto the side of the printer. You could still go further at that point, but you do not want to. If at any point this gantry begins to lift or rise, the position right before that becomes your maximum. So for me with the Ender 3, I had no issue with that, but I did hit a stop at 248, which means the value before that, 247, becomes my position max along the x-axis. And now I can write down my x value. And now I perform the same operation on my y-axis. I input the previous position max my printer.cfg had, which was 225. My print head travels there, or in this case, the bed travels there. And I start increasing this axis in 1 millimeter increments. And again, I'm waiting for the bed to hit a stop. And now at y equals 240, my bed stops. That means the position before that, 239, was the max value. Restart your firmware, auto home your machine, and now input the max values you just recorded into your coordinate system. If your print head has no problem getting to those locations, congratulations, those are your max values. We can now open up printer.cfg. Under stepper X, position maximum, enter the value you recorded for your position max. In my case, it was 247. Then going to stepper Y, I insert the value I recorded during our calibration under the position max, which for me was 239. Save and restart your firmware so this all takes effect, and we can now compute our more accurate mesh minimum and mesh maximum probing points. Based on my probe's location, my mesh minimum point is really not going to change. The only difference is going to be because we adjusted our position minimum, the mesh minimum for my probe is going to be closer to my origin, which means I will gain a little bit of extra room, namely a single millimeter. But for the mesh max position, I am going to gain a lot more than a single millimeter. For the simple version, we use the base configuration's maximum values of 225x and 225y. But now our measured values of 247x and 239y puts our print head a little further along the x and y axes. From that location, we can now compute our probe's location. We take our current nozzle position of 247x and 239y, and to it we add our probe's x and y offsets. That gives us a position of 204 in the x and 233 in the y. And that is now our mesh maximum point. We've added a little range as to how far our probing grid can gather data, which, while it may seem trivial, will contribute to better adhesion, better prints, more accurate models, which is really what we're going for. Once you have the correct mesh min and mesh max values for your bed mesh, we're going to re-enter printer.cfg, find the bed mesh section, and then re-enter those. My mesh min stays the same as 10 in the x, 10 in the y. But my mesh max changes to our new maximum, and I'm going to use the thorough version that I went over, and that's a value of 204 in the X and 233 in the Y. We can now save, restart our firmware, and begin our bed mesh calibration. To start our bed mesh calibration, we're first going to home all our axes, and then we can go through to the tune menu, where we could have actually homed our axes right through this button here. Once our axes are homed, the calibrate option now becomes available to us. We click that and the bed mesh profile routine begins. When our bed mesh calibration is finished, again, under this tune menu, we will see the visual representation of our bed. And this is our bed mesh. This is a depiction of the actual topography of our bed and how our nozzle is going to be adjusted while it prints. Now, we aren't quite finished. We still need to save this mesh data. To do that, we click this Save As button, or again, you can click the disk up here. And when we do, a profile name comes up. You can stick with default. Really no need at this point to start making different profile names. I hit Save. Klipper restarts its firmware, and then we need to add one more thing to our start print macro. I enter my printer.cfg, where my start print macro is located. And now right after this call to G28 home all axes, I'm going to add the following line. Bed mesh profile, and then we're going to load default because that is the name that we just saved it under. We can save, we can restart our firmware, and now we can start our initial print. Our bed mesh profile will be loaded and used during this print, and we're also going to do a live Z offset adjustment. I'm beginning my initial print to start adjusting my Z offset live, and I'll be doing all the adjustments right in this tool section here. The arrow pointing up brings our nozzle away from the bed. The down arrow brings it closer to the bed. And to the left, those values are the different increments, starting from the smallest adjustment to the left and the right having the largest possible adjustment. The skirt that's getting printed around it right now is where I'm checking for adhesion. I'm rolling my finger over the outside of the skirt, and I'm checking to see if it's sticking. At first, I'm not getting very good adhesion, so I begin to lower my Z offset. After a few adjustments, I'm getting some proper adhesion, and I will go on to make a further Z offset adjustment when the cubes begin to print. The first cube has finished printing, and I can see that I'm a little too far from the bed still. I want to lower my Z offset, so I make the adjustment. After the second and third cubes print, I like what the Z offset is at, and I allow my print to finish. The print is finished. I adjusted my Z offset live, and now I want to save that result. And you can see right here, this is the applied additional Z offset, negative 0.085 millimeters. Now, if I was to just restart my printer, it would go away. I need to save it, and we can use that disk right here to do so. First, let's see what our current Z offset is. Our Z offset is 3.325, and I can find that at the bottom of my printer.cfg. Now we're going to save this new Z offset. Restart, it will update our printer.cfg, and now we should have a new value under our BL Touch Z offset. Z offset 3.410. The new Z offset has saved, it has taken, and now going forward, it will apply this new Z offset. And that is how you adjust your Z offset live. After your initial print is done and you save all that information, you are ready to go forward. Your BL Touch is set up. Give yourself a pat on the back. Klipper is one step forward to being complete for you. Of course, there's always other things you want to look at. Pressure advance, input shaping. There's always something to learn with 3D printers, and of course, there's always something to learn with Klipper firmware. If you stuck around this far, I really thank you. If you want to give a thumbs up, subscribe to the channel. Going to be more Klipper videos coming out, of course. However, my next video, as far as I can tell, is going to be a dual Z belt video by Kevin, aka Sam. I've been talking about this forever, and I decided I didn't like my old video. I filmed one, I just wasn't happy with it. I've been dragging my feet with it, and because that dual Z setup is mostly 3D printed, it allows for a little personality. So that's what I did this time. I printed out all the pieces in some nicer colors. It just made the whole setup a little more enjoyable for me. So I'm happy to bring that to all you folks next. That's gonna be a really cool video. And then of course, we have more Klipper videos coming up at you. I have a pressure advance video, an input shaping video, which is using that USB-based input shaper, as well as a maximum acceleration and maximum speed video, how I set up my max accel, my max speed, and of course my max flow rate. Thank you all so much, and until next time, as always, boys, girls, everybody else, keep on printing.